Okay, so I'm going to do a few examples of using your trig identities because this is kind of tricky because it all depends on how you approach it. So first thing we're going to do here is we're going to divide by cosine. This is just another example from your notes. So I'm going to do what it says. So I'm going to divide this by cosine and then use my trig identities that I learned earlier this morning to simplify this. So sine squared over cosine. So what you can do is you can say sine and sine. I'm going to separate that square out, and that'll be what over cosine plus, this is the same thing. It's kind of like, I'll just make baby steps, cosine over cosine equals, well, what's 1 over cosine? Well, if we go look at the previous page, it's a reciprocal identity, and that equals secant theta. So let's look at this. Cosine and cosine cross out, so you're left with cosine. So it's plus cosine theta equals secant theta. Then here, what I'm doing is this sine over cosine right there is the same thing as what? Tangent. So here I'm left with sine theta times tangent theta plus cosine theta equals secant theta. So here is another trig identity and how I approached it. Okay. Now this one comes from your homework. So from your homework, it's number 4. It says multiply everything by sine squared. So that's what I'm going to do. So I'm going to say sine squared theta times tangent squared theta plus 1 equals secant square theta times sine square theta. Okay, that's the first step. Now I do the distributive property. Okay, so this is what I'm going to do to save some time because some of you like to multitask, which is awesome. So tangent square theta. So this is my first approach. What I do is I just use my identities. So sine square theta and then tangent square theta is sine square theta over cosine theta. So I just start using my identities. This is how I do it. And then sine squared times 1 is sine square theta equals, here again, I start using my identities. Well, secant squared is the same thing as what? 1 over cosine squared. And then sine squared, I normally don't mess with them if it's sine, cosine, tangent. Sometimes I do. You'll see in the future and in pre-cal. But for right now, if it's sine, cosine, tangent, I kind of leave it. Sometimes I do, sometimes I don't. But for the most part, I do. Okay, then I'm going to go back. Well, sine squared times this is sine to the 4th over cosine squared. And that makes it really messy. So changing it to this, nothing crossed out. So that's okay. That will happen. So I'm just going to leave it as sine squared theta, tangent squared theta, okay? Because it did not simplify, it did make it cleaner, it just made it messier. So you really don't, you normally have sine to the 4th, you can, but it just makes it messier. So I am just gonna leave it like this because this did not, nothing crossed out. So then, but I tried it, you should at least try it because 50% of the time it will work. Okay, then here, 1 over cosine squared times sine squared. Well, if you put this together, sine squared over cosine squared is what? Tangent squared theta. So here is another trig identity for tangent squared theta. So this is how I approach it. I usually rewrite tangent squared as sine over cosine, or I'll rewrite cotangent as cosine over sine. If I see secant, cosecant, cotangent, I'll do the reciprocal identities, and you just kind of trial and error until you get good at this. So it's a trial and error basis. You just try it out, see if anything crosses out. If nothing crosses out, normally I just leave it in this format so I just don't make it any messier. So hopefully that helps. 2 more examples for you. If not, definitely let me know and I will do some more. Okay, thanks.